Greetings to everyone. Welcome to my final year project presentation. I am Poovarashan Manimaran, a final year student in Bachelor of Mechanical Engineering with honors. The title of my FYP is Impact Tech Simulation of Automotive Build Rim using Finite Element Analysis. I am supervised by my lecturer Mr. Yusman Istihad. First, let's begin with what is finite element analysis. Finite element analysis (FEA) is a process of simulating the behavior of a part or assembly under given conditions. FEA is used by engineers to help simulate physical phenomena and thereby reduce the need for physical prototypes, while allowing the optimization of components as a part of design process of a project. Nowadays, transportation is essential for everyone who needs to go from one location to another. The pneumatic tire is one of the most important inventions in the auto industry. The vehicle wheel has been the focus of this experiment to see how it responds to to responds to pressure in various conditions and directions. The impact test evaluation of a model in order to ensure that the safety of a passenger and the driver is protected from any threat. Crashworthiness is a phrase used to describe any ability of a structure to protect the people inside it in a event of a catastrophic accident. The purpose is to determine what the example of a wheel rim means for stress and energy retention during the impact. The most frequent vehicle problems are caused by puncture tire. Factors such as rapid suddenly blow due to pressure changes, extreme surrounding temperatures, and one-up. This is important to know since in order to reduce the risk of a car collision caused by a wheel issue, the specific variables should be considered for the better result and safer environment for street users. Changes in wheels example will have significant impact on the outcome of a better examination and example of future exploration for computerization researchers. The following are the project's objectives. First and foremost, to design the 3D model for alloy rim with a different pattern and different orientations. Besides that, to determine the energy absorbed with impact tests through different pattern and orientation. Last but not the least, to calculate and compare the final results of impact test. The following are the project scopes. First of all, create a model of a wheel rim with a varying number of spokes and dimensions using CATIA V5 software. Then perform finite element analysis with Abacus software to investigate the project's model. To determine the amount of energy absorbed from impact test by the wheel rim with various spokes, counts and orientations. Lastly, to determine the condition of a wheel rim under different conditions which can contribute to further related study. The following chapter is methodology. On the right is the flowchart of the project. We look more deep uh, into the flowchart on the next slide. This project starts with the literature review. Then need to determine the rim design and creates the V-shaped striker model for the simulation. All the modifications were made with Katia V5 software to avoid any errors. Then the next step is to export all the models to Abacus software. After exported to the Abacus software, the striker model and rims will be assembled for the following step. The following step is to adding material and then setting all the parameters. Then for the important part, which is the simulation. If the simulation was a success, then we can move to the following step. If not, needed to start from the assembling of the parts. If it is a success, then we can move to we can extract the results from the simulation for the result analysis. uh, Finally, that's the end of the project. For this project, the wheel rim is design is based on my own family car, which is NASA Chitra multipurpose vehicle. The original rim had five spokes and four bolts in it. The experiment will compromise three conditions. Three conditions of wheel, which is with a wheel rim with four spokes, with shown in the picture, the first picture, and a wheel rim with five spokes, which is the original design, and a wheel rim with six spokes. The major goal of this study is to determine the energy absorbed during the impact loading, the surface area of the striker's loading site, and the result of the simulation. The striker model for this study was designed with a V shape on its contact interaction with the rim. The stress applied by the striker model can be concentrated directly on the tip of the wheel rim with this design model. The selection of the appropriate material is a critical step that must be considered in order to achieve better results in the simulation technique. Only two materials will be covered in this area of research: steel and aluminium 6061 T6. According to the studies, uh, the majority of automobile users on the road today use aluminum as their rim material. The rim materials chosen for this study were chosen because they are homogeneous and temperature independent. Steel is given to the striker model because it can withstand more destructive stress, resulting in more data and results for the test. These are the assembled view of the parts, and the striker intents must be translated to the correct place, which is at the top of the wheel rim as the initial stage of simulation. The space between the striker model and the wheel rim is fixed at 0.4 mm, which has no effect on the consistency and the precision of the output because the mesh size and the material utilized are the only factors that affect the outcome. Three alternative number of spokes were used in the test simulation, all with the identical setting and orientation. The striker model has a speed of 22,202.22 millimeter per second and is directed to make contact with the wheel. The deformation occurs where the V-shaped cycle comes into contact with the wheel rim, as shown in the table. The bar chart shows the energy absorbed the wheel rim with varying number of size and the number of elements. Uh, the six-spoke wheel rim absorbs the most energy of all the wheel rims. In this section, the results of a first study on wheel rim impact estimation providing rim in future research. The wheel rim is chosen for this investigation as five spokes uh, that that will be subjected to impact testing in three different orientations: 0 degrees, 18 degrees, and 36 degrees. The rotate translation is used to translate the orientations using Abacus software. The 0 degree orientation is positioned in the center of the spoke, which makes the simulation test from the previous slide. The 36-degree angle begins at the center of the rim flange between two spokes, whereas the 18-degree angle begins at the center of the wheel rim spoke. The absorbed energy will then be quantified and analyzed. The deformed and undeformed structure of the wheel rim before and after the impact solution are presented in the table. The absorbed energy ranges from 596 joule to 999 joule, as indicated in the graph based on the energy absorbed by the each wheel rim with varied number of spokes. The percentage difference derived from the simulation is less than 15%, implying that the amount of energy absorbed remains nearly constant as mesh size lowers. In contrast, the percentage difference of 0 degree, 18 degree, and 36 degree were also obtained for comparison purpose. The area of contact between the wheel rim and the striker model, as well as the different orientations involved, are the reason for this clear result. The last disparity in energy absorbed during the simulation is due to the area of contact between the wheel rim and the striker model in the study, which is the shape of striker model, which is V-shaped. The location of impact in the 0 degree orientation is positioned in the center of the spokes, with the support of the spoke allowing more energy to be absorbed from the simulation, whereas the 18 degree and the 36 degree positions are located at the in the gap between the spokes with no support from the spokes. As a result, there is noticeable variation in the amount of energy absorbed. That's all from me. Thank you.